Good afternoon, everyone, and welcome to our latest Hips and SIPS webinar. So just to run you through the schedule for today, I'll proceed with a slideshow interspersed with some live demonstration. This will take about 30 minutes, and there'll be some time at the end to answer some questions. Presenting today is Burns Foster, that's me. I'm the product manager for Hips and SIPS, and Matthew Gudger, who's one of our veterans from the Hips and SIPS support team.
That's me. Hello, everybody.
So just before we talk about Hips and SIPS 8.0, for those of you that aren't existing clients, CARIS is a company that provides GIS software mostly to the hydrographic and marine communities. CARIS has been in business for almost 35 years, and our software products are used all over the world. We have about 170 people in 4 offices, most of those in New Brunswick, Canada, and we focus primarily on marine GIS, and we've done quite well in that industry. And for any that aren't familiar with Hips and SIPS, it is a comprehensive sensor data processing system. Most of our clients use it for processing bathymetric data like side scan and multi-beam, but we also have clients that use it to process LiDAR and laser scan data. These sensors all work on the same principles, so our tools are easily adapted to it. And we support over 40 industry formats, so you're not tied to a specific hardware platform either. Something we're also well known for is handling large volumes of data. We have clients that process gigabytes of data in Hips and SIPS every day.
We have a full suite of automated filters which are great for cleaning any kind of systematic noise, like bubbles at the transducer face or bad beams. We also have a full set of manual inspection tools, so you can do line-based editing, or you can use our popular subset editor for area-based edits. This lets you visualize and clean georeference point cloud in a 3D view. Another great thing about subset editor is that you can view overlapping survey lines at the same time and even load at a gridded surface while you're validating data.
We also integrate a robust total propagated uncertainty estimation directly into our workflow, which you can use to measure, evaluate the quality of, and even filter your entire data set quickly and easily. This can also be fed into the cube gridding algorithm, a cleaning tool provided by the University of New Hampshire, which has become quite popular in recent years. Hips and SIPS has been in use for more than 20 years now, and we've been pushing the boundaries in this part of the industry. Hips and SIPS is also an integral part of the larger CARIS ping-to-chart solution, which many of you are likely already familiar with. Okay, so today we're here to talk about some of the great new features in HIPS 8.0 and even give some live demos. There's lots of new features in this version, but we have just enough time to cover the big 3. The new calibration tools, the introduction of the HIPS file, and ray tracing of water column imagery. We'll also give a quick demonstration of each of these as we go through. Okay, so first, I think everyone, including us, has been waiting a long time for this one. We finally removed the old HIPS calibration tools and hooked everything up to our subset editor. Like the tagline says, the workflow is the same, meaning you still run a standard patch test procedure in the field and calibrate sensors in the same order in HIPS. But the great part is we now have it tightly integrated with the popular subset editor, which already has a lot of useful tweaks and functions our users already know how to use. We've also made a lot of improvements to the interface, but I think the best way to show you that is with our first live demo.
All right, Burns, this would be a great opportunity to show everyone the new, show them the new detailed line query, well, the old tool, but the new place for it.
Yeah, definitely. So in the older versions of the application, the detailed line query was something you had to go into tools options and you turn it on or off, and it would run every time you made a selection. And what it did was it compiled a bunch of statistics and other information about the lines, and sometimes it'd really slow you down. So now in HIPS 8.0, we've turned it into a real process. So now it just sits here. I can run it from the process menu. It's going to execute on those lines, and it's going to pop up in a window with all of the detailed line query information. So it usually shows a lot more than this. We filtered it down for just what's useful for calibration. So now the great thing about it is if I change my selection and I keep working in the application, the window stays the same, so it's not going to rerun every time I move around. It's only going to run again when I tell it to. Okay, so I already know what I need. I'm just going to close that window out, and I'm going to open my subset here into my 2D slice, and I'm just going to rearrange that here in the display. Move my toolbar out of the way. Load up my slice, and I'll also set up my view. So I'm going to change to color by line. And I'm going to turn off everything except the couple patch lines that I need. So I've got AB5 and BA5. So this is the familiar HIPS and SIPS training calibration data set, so I kind of know my way around here already. The other thing some of you may notice was, you may remember the old track line color map used to color lines on the display. The thing was, it only had 8 colors, so sometimes, of course, if you had more than 8 colors, colors would start repeating, and then things might get hard to see in the display. So we added this 45 colors color map. I actually got one of the graphics design guys to give me sort of a random color palette with nice high contrast, and that ended up as this new color map here in the 8.0 release. Okay, so I've got my display configured now, my 2D slice, and I'm going to open my calibration. So it's here is another layer in the subset controls, and all I have to do is hit start. So what's happening in the background here is all of the soundings I can see are run through what we call a mini merge. So essentially everything is merged on the fly based on the settings I enter in the calibration. So I can choose what sensor I want to calibrate. So in this case I have a dual head system. Let's say I want to pick transducer 1, and I can choose which sensor property. So pitch, roll, or yaw, and then I can control it here. So I can type in a value, for instance. Let's say I want to set it back to 0, and you can see it's updated here in my display as well. Just going to adjust my slice a little. So for a coarse adjustment, there's a slider tool right in the calibration window, so I can use that to kind of hone in on a rough value for my pitch in this case. And I know it's going to be somewhere around there. And then I can use the blue arrow tips here to increment by 1/100th of a unit. So I can move around that way, or again, I can just type in a value into the field. I know it's going to be about -9.1, and that gets updated right in the display. So I can run through, like I said, the standard workflow still applies. So I run through all the sensors in the same order, and then when I'm finished, I hit stop. It'll ask me if I want to save changes. So if I say yes to that, what it's actually done is saved it back out in the HIPS vessel file. So I can go into the vessel editor, and under transducer 1 and pitch, there's my -9.1. So you don't have to switch back and forth between the vessel editor and the application anymore. All right, so that's it for calibration.
All that's left now is to re-SVC and merge your data, and everything's going to be up to date.
Exactly, so, okay, we'll just close that out. So one of the biggest changes in this release, although it's not really obvious in day-to-day use, is the introduction of the HIPS file. Basically, for each project in HIPS, we used to store a HIPS project file, or HPF, which stored some basic information in a text file about the coordinate system, who created it, and a few comments. Pretty limited, really. So we've replaced that with the new HIPS file, which is actually a SQLite database, which does a whole bunch of extra stuff for us, too.
The first obvious change for everybody will be just trying to open a large project. HIPS needs to track various things about every survey line when opening a project, and in the past, that information had to be read every time you opened a project. Now, if you had a few thousand survey lines in a project, that could take a few minutes or more just to open. With the HIPS file, that information is being stored once in the database, so HIPS can skip that step entirely and just show you the data straight away. Now, Burns, previously, I was able to drag and drop my HPF file into HIPS. Can I still do this with this new HIPS file?
Actually, you can, Matthew. In fact, you can drag and drop any of the supported formats right into the HIPS window, including the HPF or the HIPS file. If you drag in an HPF or even just open an older HIPS project, HIPS will automatically upgrade that to the new HIPS file format. So part of what makes all of this possible in HIPS and SIPS 8.0 is treating everything as features and storing those features in the database. So all of your survey lines, critical soundings, and side scan contacts are now just features inside a database with some attributes associated with them. That's actually going to open up a lot of neat things in the future too, but I'll tell you about that later.
Now, another problem that clients often have with managing multiple users on large projects. What can HIPS 8.0 do to help them with that?
Right, so in earlier versions of the software, you had to be really careful about divvying up the data between users. The problem was we didn't really have any way of tracking this inside the software because it's really hard to get useful information about who has what files open, especially if 2 people on 2 different workstations are using it. So the answer to that is a database. A database is built from the ground up to manage multiple users all working with the same data. So the HIPS file gives us that capability, and with it we track who has a line open and why. If someone tries to open a line that's already opened by someone else, they'll see a warning message. The HIPS file also had an impact in the application. one of the consequences of introducing the HIPS file is the application isn't opening a bunch of separate line file folders anymore. It's opening one database with all of the data in it. So that means we couldn't support opening a single line or a group of lines in the application anymore. To replace that, we came up with making the project window behave a bit more like the layers window by adding checkboxes to everything. So that lets you turn lines on and off in the display, and when they're off, they behave as if they aren't even open. So they don't show up in the editors and processes won't be applied to them.
As a HIPS power user, I would often move and copy files in Windows Explorer so that I could test data. How will that work with the new HIPS file?
Right, so for the power users out there, with the database, you can't really move folders around on disk to reorganize a project anymore. So what we did is we made sure you can cut, copy, and paste between days, vessels, and even other projects right from the project window. And finally, we also brought back the recycle bin, so when you delete a line, you have a chance to bring it back. So it's a good time to show you all of that. So basically here I have, it's actually an older 7.1 HIPS project, so you can see the old HPF file here. And we've already opened it in HIPS 8.0 and it's automatically upgraded with this with the new HIPS file. So I can just drop that straight into HIPS, open it that way. And so now I can show you some of the controls inside the project tab. So it still looks pretty much the same, except like I said, we've got these checkboxes on everything. So what I can do with that is I can turn off individual lines in the display, or I can turn off a whole day, or even an entire vessel. So when they're off, any editors, so let's see, if I turn off this line, you'll see my editors can't be open, so it's as if the date is closed, so HIPS won't even recognize it. And any processes, even if I select the whole project, won't get applied to that line. So the other thing we mentioned is you can copy and paste between lines. So let's say I want to copy, say, this line, I want to copy, and I can paste that up into this day. So that's doing it on disk at the same time. It's moving that folder over, and there it shows up underneath this other day. And the neat thing about all these, so anytime somebody does something to the project, this is where that multi-user stuff comes in now. So we have this message down in the output window that says, hey, a user did this to a line. And that'll show up for all users that have this project open. So I have a second user that was had this data open at the same time. They'd see this message appear in their window as well, so they know that something changed. So I could also take this data and I could delete it. So let's say I can move it out to the recycle bin, and that's moving it over. And there it is. So that shows up underneath my recycle bin. And of course I could go in, I can empty it just like you do in Windows, or I could restore it, and that's going to put it back in the same place inside the project. And once again, a message appears for each one of these operations, and in fact the deletion even shows me who did it. So what user deleted that line, and that gives me their Windows login as well. Okay, so that's it for the HIPS file.
Next, we're going to move on to water column.
Right, so probably the coolest new feature in HIPS 8.0 is our ability to ray trace water column imagery and produce georeference bathymetry from it, from either Redesigned or Kongsberg sonars. You can do this from both swath and subset editors, and we really put a lot of thought into making this as easy as possible for the user. So it's as simple as a right click in the display. There's no exports, no separate processing. HIPS does all the work for you. So to make this a one-click function, we had to figure out how the user could configure the various processing options, like what tide to use, what sound velocity needs to be applied, and so on. The simplest answer to that was to just use what we already know about the data. We just apply whatever has already been applied to the standard bathymetry in the same line. So in the standard bathymetry, if you've already loaded a tide file, applied a sound velocity correction, or even loaded and applied some post-process motion or navigation, that's going to get applied to the water column bathymetry as well.
That would be the workflow for Teledyne Reson and Kongsberg sonars, but what about Kongsberg users who aren't sound velocity correcting in HIPS?
Oh yeah, so Kongsberg users are a special case. Because those systems apply most of their corrections in acquisition, you can skip those steps in HIPS. We manage all of that seamlessly in the application, and if the user has a Kongsberg sound velocity correction license, we'll use that to ray trace the data. And if you don't, standard UNB ray tracing is used instead. And of course, for Teledyne Reson users, we use the same sound velocity correction you apply to the standard bathymetry. So what happens to this once you create it? Well, once you've created this ray trace bathymetry, we store it in our Caesar point cloud format, and it will show up in HIPS as a child layer of the HIPS data. After that, it works the same as your normal bathymetry. It'll show up in swath and subset editor. You can query it, you can reject it, designate it, even use it to create a surface. Everything you can do with the normal bathymetry. You can even run compute TPU on it and use it in the uncertainty or cube surface creation.
One really interesting thing that Burns brought up there is now we're actually supporting 3D point clouds and CSAR data in HIPS and SIPS. Previously, we could only open those up in Bathy Database Editor. So what you see here is some data that we looked at last year during the Service Pack 2 webinar showing our first release of water column data. So I'm going to go ahead and I'm going to open up this data in Swath Editor, and this is a recommended process from us. Because there's so much extra data with water column, it's better to open it up in here, take a look and see what we can do to apply filters so we don't have to load as much data into Subset Editor. It just makes everything work much more seamlessly. So I'm going to go ahead and I'm going to use the find tool here, and I know that somewhere around ping 2178 I'm going to find an interesting gas seep. So I'm going to spread my filters out a little bit here. Another thing we can do right now, we're actually just looking at one profile in the across track as well as the along track view. So the along track view, we're just looking at the nadir beam, and in the across track, we're just looking at one sonar ping. But if I check this box here to enable the stack view, we can see all the data in our plan view is sandwiched together, and the strongest return is given back to us with these options here. And we can do a little bit of filtering there. Hopefully you guys can see there's a bit of a gas seep coming right up here through the middle of the data, and you can also see it here in the along track view. So what I'd like to do is go ahead and select this data. So what I'll do is I'll use this from the water column toolbar. We have this new tool called select. So I'll first select, and I'm going to switch over to the lasso tool because it's going to allow me a little bit more definition when I go in here. So I'm just going to take that, hold down my left mouse, and drag a little circle around all this stuff. And we'll go right click to close that selection. And here we go. We're going to have everything selected here. And then I can go and right click, add selection to additional bathymetry. As you can see from the data that I've selected, I've got a little bit more than what just the gas seep is. So I went ahead and added this earlier this afternoon, went in, cleaned the data out, and I've got a cleaned additional bathymetry layer for you here, and that's what you see in this gray area here. So the next thing I'm going to do, I'm going to take this and show it to you in our 3D view. So we can turn on the depth from our bathymetric source, and I can also turn on the depth from our additional bathymetry layer, and we can see the properties here in the properties window. I'm going to take the point size, increase it to large. I'm going to go in and have a look at this gas seep. So you can actually see the gas as it's rising up from the seafloor. Pretty neat. So if you're interested in anything like gas exploration or the oil industry or even fish, you'd be able to view all that stuff in here. We also have a whole lot of users for HIPS and SIPS that are looking at getting a shoaless depth and recording for charting purposes. So the next thing we'll do, we're going to go ahead and we're going to open up the session, and we're going to take a look at the GB Church, which is shipwreck data. We looked at this in last year's webinar. And we're just going to take a look at it in 3D view. I'm going to change so that I'm coloring by depth in this case. And Burns already pointed out earlier in the webinar, calibration was added into the Subset Editor tab, and we're going to go to the water column section, and we've got some filters here. I'm going to go ahead and make sure I do load my subset, and with that loaded, we can see that I can now load my water column data. The filters that I had set in the Swath Editor are remembered and brought forward into the Subset Editor. I can select load, and as the data is loading, I can still move everything around. And when it's ready, I can select open, And now we can see all this extra bathymetric data. We can really see a lot of the superstructure of the ship showing up now. We can clearly see the mast. We can see a lot more of the wheelhouse. We can see a little bit more of the structure here. So what I can do from here is, again, with the water column selection selected, I can select that data. I can right click and add this to additional bathymetry. It takes about a couple of seconds here, and we'll be able to come in and see that that water column image data has now been turned into bathymetry. And now that it's turned into bathymetry, we can go ahead and treat it just like any other bathymetry in HIPS and SIPS. So if we come up to the HIPS data section, we can actually select some of this data. We can reject it. We can come over to this mast. We can select it, and we can do a find designated, and then we can use that designated sounding in order to populate our base surface. So one more little change to the workflow. If you want to take that and use that shoulder depth to report in your newest base surface, we go ahead and create a new base surface. We'll call it test. And in step 3, you'll see this checkbox here to include additional bathymetry in your surface. You simply do that, and you will have added all that extra data
Right into the grid. I
Right.
like it.
Alright, so some of you may be aware of CARIS's recent partnership with EIVA. CARIS and EIVA tools are being integrated and packaged together to perform an optimum solution for offshore survey. And here's a quick overview of our streamlined solution.
Right, so sensor data is logged using the EIVA NaviPack and NaviScan software. And NaviScan is where the multi-beam data is logged, and these packages are kind of on the far left of the diagram. For sensor processing, we use the EIVA NaviEdit and CARIS HIPS and SIPS. So in this workflow, the main role of NaviEdit is to post-process subsea positioning data from, say, USBL. And this processed nav can then be loaded into CARIS. So once in CARIS, multi-beam processing can be carried out. So this includes georeferencing the bathymetry, any imagery, and also water column data if available, and the application of various corrections like sound velocity, tides, or a computation of total propagated uncertainty. From there, further processing and pipeline inspection tasks like free span detection, bending violations, and video review can then be carried out in EIVA Navi model. The data can then be presented on an alignment sheet using NaviPlot and loaded in CARIS Bathy database, which is an enterprise GIS system built with survey data management in mind. Bathy database is built on Oracle Spatial or the free Postgres SQL database, and its primary purpose is to manage all of your survey data sets and the associated metadata. From Bathy database, features can be exported to GML and soon CBEDML as well, which is the open exchange format for SSDM, which I'm sure some of you have heard about. It also allows you to share data with your clients and colleagues through the web, and this is achieved through Spatial Fusion Enterprise software, which is an OGC web map server. Okay, so just before we finish up, we thought this would be a great time to mention some of the new features coming in HIPS and SIPS 8.1 this summer. The biggest changes you'll see are on the SIPS side. We've basically rebuilt our tools from the ground up for processing side scan imagery. First, we've enhanced our format support to support 32-bit imagery instead of 8-bit, which means a better quality product out the other end. For processing, we borrowed some technology from the multi-beam side of things. So all of the side scan processes now take advantage of multi-threaded processing, which actually made it fast enough to do it on the fly inside the side scan editor or waterfall display. So previously, you'd run a slant range correction and then you'd wait, and then you'd run a beam pattern correction and wait. So now you simply check or uncheck a box and you see the results right away without waiting for those processes to complete.
We've also made SIPS more intelligent. So for instance, instead of forcing the user to say, calculate the slant range correction values themselves, it's automatically calculated for you to always give the best resolution. We've also removed the requirement to create geobars for each line before you create the full project mosaic. And you'll be able to go straight to the full mosaic.
Yeah, that's right. We also mentioned earlier that all of the HIPS objects are stored as features in the HIPS file. So in 8.1, you'll be able to extend those features or even add your own. There's a sneak peek in the image on the right under that object browser, but basically you can add your own attributes to the existing HIPS objects, like adding your own critical sounding attributes or adding new side scan contact types through this interface. A couple other things to watch for. We've incorporated one of the base editor gridding methods, the shoal depth true position grid, so that will become another gridding method choice in HIPS. We're even extending it a little, and we've added an optional median band calculation to that format in addition to the shoal and deep bias bands. And finally, we've had a lot of positive feedback about our color by SV profile feature, which basically colors the survey lines by which sound velocity profile was applied to each ping. So in the same vein, users will now be able to color by which tide was applied. So when you're using multiple tide stations, you can see graphically how that influenced your data. So there's lots of other great new features in 8.1, but you'll have to wait and see.
All right, keeping connected with CARIS is really easy. You're already viewing today's webinar on the CARIS YouTube channel. You'll also find us on such mediums as Facebook, LinkedIn, Twitter, and Google+. CARIS is going to be attending some events in the coming months. You can always check our website, caris.com, for the details on what conferences we'll be at and where an open training session will be in your area. Thanks for joining us today.
Thanks for watching, everybody.